So this was a project that we did for the Goddard Space Flight Center, NASA, specifically with the intent of publicizing and doing outreach for the James Webb Science Telescope project. Right now they're sort of building buzz about it, and one of the things they wanted to do was have a bunch of visuals that sort of explain what the James Webb Science Telescope might help us discover that the Hubble hasn't. What we're doing here is the molecular cloud simulation actually has a really incredible level of detail, and you can see protoplanetary disks, which are early solar systems basically, forming, but you can't see them in a lot of detail. And so then we crossfade to this protoplanetary disk that's in a lot of detail because it's the entire simulation. And when you get close to that, you can actually see these lumps forming near the center of that disk, and that is supposed to show the creation of planets. So one of the steps at the beginning of our process is we look at reference imagery. In this case, actually, we didn't really have to conceptualize of anything because all of the imagery was really already in the data. The first thing we need to do is we need to understand what the data is. We'll get the data, and then we have to figure out how to turn the data, which is just a bunch of numbers, into a format that our software can read. And then once we finally read the data and we can spit it into our visual tools, then we have to go and explore the data to see, are there errors in the data? Are there boundaries that we need to be worried about? And just, what is in the data? This video is a compilation of two data sets. One which came from Alexey Krytsyk, who works on astrophysics of molecular clouds, and another data set which is from Aaron Boley, and he did a simulation of a protoplanetary disk, which is a sort of a different scale of detail. And so what we've done is we've choreographed, Bob Patterson in the group has choreographed a camera path through the data, and then we import that same camera path into the other data set. And I suppose we did enhance it a little bit because there were certain, when you get close enough to data that's not very high resolution, it starts to look like it's not high resolution. And so we added some detail so that it seemed like it was a bigger object, and we sort of not only try to come up with something that's visually appealing, but also something that's explanatory, something that actually shows you what's going on in the data.